In section 6 of chapter 10, we're going to do some practice on working with your calculators and some of the skills for getting the common logarithms. Remember, this is base 10, and natural logarithms, base E. And this is what we'll be doing. Now, one of the first skills is to be able to translate from one form of log to the other. And just as a little review here, let's see. We said this was exponential form, where we had the base, and then we have an exponent, and then this gave you the answer. Now, to convert that to logarithmic form, remember we said log. We put our base here. Our answer goes here. And our exponent goes there. So following this, let's just do some conversion. So we know this is our base 10, so we can put log. We could put the 10 there or not, but this is common log, so we don't need to put it there. Our answer is going to be 10,000, and our exponent then is 4. So following that same pattern, log, it's base 10. Now our answer is 0.01, and our exponent is -2. Now again, it's base 10, log. Our answer is 6.3, and our exponent is x. So a little review of what we've done, but again, good practice and through drill will help us move along. And there are the answers in a formal way. Now, whichever calculator you're going to be using, you need to practice then how to use your calculator to get results. So here they're featuring the TI-84, where there is a log key. So you would hit the log key, then it displays a place where you are to put in the number you're searching for, and then you put a close parenthesis, and then you enter. So let's do some practice for this. Log, and then you're going to get a single parenthesis there. You're going to put in 200, close the parenthesis, and then enter. And then for each of these, see what you get. So for letter A, it will be this, and it's accurate to the nearest billionth. Wow. And B, and C. Generally, these small numbers are going to give you negative answers. Now remember, these are the exponents. So if you put in your calculator, and you might give this a try. Remember, this is base 10. So base 10, caret, and then you put in this, and you go as far as you can on your calculator. It's going to equal something close to 200. Give it a try. And here they're showing you the screen of what your calculator screen would look like. Now, we can also use your calculator to find the inverse of a log of value n. And again, take a moment to try this. In this case, you're going to press your second function, then the log key, and then 10 will show up along with the caret. And you just put your n value in there, put a close parenthesis, then press enter. So let's try that. So let's do the first one together here. You're going to do the second function key. Then you're going to hit log. And then you're going to put in 5. And then a closed parenthesis. So take a moment and try that. Okay, I just tried it, and actually on mine it didn't need this parenthesis, although if I did use it, I got the same answer. And as you can see, you probably got, let's just click that, $10,000 or $100,000, I should say, for this one. And there's the answer for B. Notice negative exponents give you this. And there's C. And D. Now, as you look at this, this is 10 to the 16th power. Notice they're showing this in scientific notation, sort of. So E is 10 to the 16th power. Take a note of this. This will show up on your calculator here. And its exponent 10 to the 16th over here. And that's what they're indicating here as well. The E is the calculator's version of the scientific notation. So that translates to this. Okay, now what we're going to do is, again, take a moment. We want to convert natural logarithms in this form. This is the exponential form. And again, you're copying this in your notes. This is your reference. This is what I'll be checking when I do a notebook check. So let's do this. So we know our base, since this is a natural log, will be natural log will equal, well, not equal anything yet here. Natural log of our answer here will equal the exponent. So the natural log of our answer, which is 1, equals our exponent. Natural log of our answer equals the exponent. And there we see it officially. And I like what they've done here too. Again, we're using that same basic form where base exponent equals answer. And then natural base, again this is E, of the answer equals the exponent. And if you have to make that little chart as you do things, do it a couple of times and that will fix it hopefully into long-term memory. Alright, let's go on. Now for using your calculator when you're dealing with base E, there is a key IN, or LN I should say, natural log. You just put in your number and then usually a closed parenthesis, then hit enter. So let's check these out. Again, have your calculator handy, and this is example 5, natural log of 1, natural log of 3, and natural log of this. So natural log of 1 is going to be 0. Remember, anything to the 0 power is 1. And then for 3 is this. And for 0.2 gives you a negative value for these small numbers as a rule. And there's what it looks like on a calculator. Again, pause as needed to get these notes down. And then of course you'll be doing your practice and certify. Now we can also use the inverse of the natural log. Now remember, if you're using exponential notation, you would use the inverse. If you're using logarithmic notation, you use the straight logarithmic form. So this is similar to what we did before. You're going to hit second, natural log, then E with a caret will appear. You put your number value in, usually close parenthesis, and press enter. And let's give it a shot here. And like before, I didn't need to put in a parenthesis. It gave me the answer with or without a parenthesis. So as we check these out, you get this. Here. Notice negative exponents indicate smaller numbers. Now, notice this is e to the 50th power. Wow, that's going to be a big number. And again, it's the way your calculator shows scientific notation here. This would be 10 to the 21st power, as they're indicating here. All right, this is some basic material for you to be able to use in our last section of Chapter 10. And again, you're putting in your exponent here using the inverse function of natural logs. By the way, if it's of interest, when I went to high school, and back in those days, we didn't have calculators. We had to look all these logs up on charts and through arithmetic figure things out. So what a good deal we have with the use of calculators here. Okay, we have a little time. So if you'd like, you can try these and pause as needed. And these are the answers. Now, going back to number 9, you might say, why is that undefined? Because, as you see here, this is a log of a negative value. We said logs of negative values were undefined. Now notice this differs from number 10 down here. Here it's the exponent that is negative. Here this is the answer that is negative. We have that is undefined. Okay, we'll wrap this up with less than 20 minutes.